Hey, my name's Sihota, and I'm going to go over a problem in the Rhind papyrus, number 28. A little bit about the Rhind papyrus. It's one of two major mathematical artifacts from ancient Egypt, the other one being the Moscow papyrus. One of the main uses of the Rhind papyrus was for scribes to train other individuals or just have them copy down information from the Rhind papyrus so they could learn as trainees. So I'm going to go over this problem right now. So the problem states, solve by the method of false position a quantity and its 2/3 are added together, and from the sum 1/3 of the sum is subtracted and 10 remains. What is the quantity? So first I'm going to talk about the method of false position. The method of false position is basically like a guess and check method, but without the checking. Basically, you would assume an unlikely but close estimate, and you would basically like plug and chug. So the basic formula is x plus 1 over a, x equals b. That's one of the basic formulas for false position. I'm gonna translate this problem into like modern day English, or modern day math, so it's more understandable. So this would be x over x plus 2/3 x minus 1/3 x plus 2/3 x equals 10. So what Egyptians usually would do is, since the denominator is 3, they would assume that x equals 3. So in this specific equation, you would assume that x is a. So we're going to first assume an x. So since the denominator is 3, we're going to assume x equals 3. So after plugging this in, we get equals 10, which basically equals to 10 over 3, which obviously doesn't equal to 10. But this answer we're going to use, and we're going to divide this original b, which is 10, by 10 over 3. What we get there is 3, another answer of 3. This result, we're going to bring this down, and we're going to multiply 3 by our original assumption, what we assumed x to be, which is 3. We're going to get 9. So basically what they would do is, after dividing the original b by the answer found after the assumption, they would multiply it by the original assumption to get something close to the answer that they're looking for, which is 10. So 9 doesn't equal 10, but it's close enough, and this is basically the method that the Egyptians would use in solving one of these problems by the method of false position.